Okay, we're picking up with the previous example of putting $1,000 into a bank account which pays 3% interest. The second part we need to ask ourselves is, what formula would give the account balance at any given time? So when we're talking about the actual amount in the account, we will not be using our rate formula. We will be using our A equals P times E to the RT formula, since A gives the amount in the account. So make sure you're differentiating between the two. This is why I'm doing this particular example. Again, we could use our population model that we proved in our previous proof, but we've shown that this is the same as the A equals, some people just say A per, but it basically means the amount is equal to the principal times E to the RT. Again, T is typically in years. Keep that in mind. It's not seconds, minutes, or days. Okay, so first of all, we're going to write out what we know. We know that the rate is 0.03, and we know that the initial population is, the initial principal, the initial amount you put in the account is $1,000. I'll even put my dollar sign here. Next, we want to plug into the formula, and since we're using the APERT formula, we're just going to plug that straight in. And I'm actually going to show that right here. So notice we're just plugging in 1,000 for P and 0.03 for R. And that actually answers the question. That's all this example is really doing, is just coming up with a general formula for the amount in the account. Now, why do we want to know general formulas? Because if you open this account up, you would want to know at any given time, however many years later, how much you have in the account. So if you plugged in, let's say, 33 in for T, we're going to get about 1 back here for the exponent, right? 0.03 times 33. So it's basically going to be 1,000 times E, which is about 2.718. So you have about $2,700 in the account, which isn't that much really, right? After 30 years. That's why you want to really put a lot in the account. You can then see why it's important that your principal is bigger, because if you were to put in $1 million, then after 33 years you'd have 2.7 million. So that's it for this example. It's just asking for a general formula, which is useful, especially when you're talking about money in an account that you open. If you have any other questions about this example, let me know.